Hello, my name is Luis Salazar and I did a 3D CAD of a single piston engine for MA52. I created 22 distinct parts for this model. The entire assembly consists of 49 parts. To bring it together, I did 114 mates. I utilized colors to exploit the parts. For instance, the engine block is gray cast iron, the cylinder head is red steel, and the carburetor is both iron and steel. I used the XTM 24.7 engine as my model. This is a clip of the motor in action. I first unassembled the engine so that I could take measurements and visualize this complexity. I created a new shaft, pull starter, bolt holder, connecting rod, piston, and wrist because I could not view them completely. Starting each part was an obstacle because I predicted step by step what the creating process would be. To create the parts, I used swept, extrude, revolve, lofted, shell, mirror, 2D and 3D sketches, and much more. Extrude, swept, and reference geometry were the three features that I used the most. In some of the parts, I created sketches that guided every other sketch. I placed extensive detail on each individual part. Every single part of my assembly was designed to fit together. To improve the visual appearance, I added labels, stamps, gears, and a SOLIDWORKS settings. I created the display stand and flag shaft to make the engine more appealing. Several different mates were required to make the engine function as expected. For the gears, I used advanced mates. Mating planes parallel to each other was used for all other rotating components. The piston moves up and down because it is connected to the shaft and is concentric to the engine block. If the shaft was to jam, I calculated that the max applied force would be 41.2 pounds. I tested the 0.2 in diameter alloy steel shaft with 2 simulations. Approximately both simulations resulted with a max displacement of 0.005 inches and max stress of 74 psi. The max stress is in the elastic region below the yield stress, so the shaft will not be deformed after the shaft is unjammed.